So this is the last topic which is related to astrophysics and cosmology. In this topic, we'll discuss the gravitational field strength, as well as we'll compare the gravitational field with electric field and different laws which can be used to find the size, the distance, or the power or luminosity of different stars. So the first part is Newton's law of gravitation. What is Newton's law of gravitation? Newton's law of gravitation basically state relation between the force of a gravity between the two objects. And what this law state, it state that the force of attraction, because gravitational force is always attractive force, so he said the force of attraction between the two masses, like if m1 and m2 are the two masses and they are attracting each other, so force of attraction between the two masses is directly proportional to the product of the mass. So greater the product of the mass, greater the force of attraction between the two masses. And it is inversely proportional to square of the distance between the. So when we take the distance between one center of one mass to another, that we call r. So he suggests that that force is inversely proportional to square of the distance between the two masses. Means if we double the distance, the force will decrease by factor 4. If we triple the distance, the force will decrease by factor 9. So how we can relate if we want to find the gravitational force or force of attraction between the two masses? So we can use this Newton's law of gravitation, and according to that, the force of attraction, because gravitational force is always attractive, so force of attraction is directly proportional to product of the masses, and it is inversely proportional to square of the distance between them. Whenever we replace the proportionality sign we replace with equal to and constant. So G is a gravitational constant here, which is having a value of 6.67 into 10 to the power minus 11 Newton meter square kilogram minus 2. And we place a negative sign here. What is the meaning or what is the significance of a negative sign? Negative sign shows that this force is always attractive. Like gravitational force can never be repulsive. So if we want to find the force of attraction between the two masses, we can use this formula. So we can also use this formula to work out the mass of the Earth, and the gravitational field is also a radial field and the direction is always towards the center. So if we want to work out the mass of the Earth, how we can find, using this Newton's law, how we can find the mass of the Earth? So example, this is the Earth and there is an object placed on the surface of the Earth. Because the object, the distance from center of mass of the object to the center of the mass of the Earth, that will be approximately equal to radius of the Earth, because the size of the object is negligible. The mass of the Earth is given by me, mass of the object is small m. So according to Newton's law of gravitation, that F, the force between them, is equals to G, the mass of Earth m1, the mass of object small m, divided by distance between them, so that will be radius of Earth square. The force by which, so object is pulling the Earth is pulling the object, both have the forces always act in pairs. The force which the object apply on the Earth will be same as the force Earth apply on the object. So this force is F. And for object, this force will also refers to weight of an object. Like the force by which Earth is pulling the object towards its center, that is also known as a weight. So for this object, we can say force is equals to weight, or weight is mg. So in place of F, we can substitute mg. So we can write mg is equals to g, the gravitational constant, mass of Earth, mass of object divided by radius of Earth square. When we simplify, you can see m is common both sides, so m can cancel with m, the small m cancel out. So what is the mass of the earth? So g is the value, the acceleration due to gravity, multiplied by radius of earth square divided by the gravitational constant. So what we'll get the mass of earth. And here our assumption is that we assume, because the radius of the earth, it is like earth to be a perfect sphere, or its radius is constant, and the value of the g, the value of the gravity on the surface of the earth, also we assume to be constant. So when we take the radius of the earth, the constant value, as well as the gravitational constant and the expression due to gravity, so we will get the mass of the earth. So this is a comparison between the electric field and the gravitational field. The force between the two charges, that is known as we will use a Coulomb's law. When we use a Coulomb's law, that is F is equals to K Q1 Q2 over R square. And the gravitational field is used to find force between the two masses, which is given by a formula F is equals to G m1 m2 over R square, or capital M small m over R square. The strength of the field, how to find the strength of electric field? Electric field is force per unit charge, that we did in unit 4. And to find the gravitational field or strength of the gravity, it is force divided by mass. If we want to find the field of isolated charge or isolated mass, means the charge is alone, it's not affected by any other nearby charge, so we can find the strength by using a formula kq over r square. And if we want to find the gravity, the strength of a gravity for isolated mass, then it will be given by a formula gm over r square. So they have the similarity. You can see the constant for electric field is k, whereas constant for gravitational field is g. The origin of the electric field is charge, and origin of the gravitational field is a mass. And there is always energy conservation is there. That, like example, the electrical, here what happened, like the electrical energy equal to work done, and in this case the same thing, the gravitational potential energy will be equal to work done or kinetic energy. Like electrical energy can be used to do work done on a charge, whereas gravitational energy can be used to do work done on the mass. Then how they are similar, what are the similarities, and how they are different from each other? So what are the similarities and how they are different from each other? Similarity, both types of fields have infinite range. Like we cannot say that the electric field is acting at a distance of 2 meter and then suddenly zero. No, it can have infinite range. We cannot limit the electric field strength or intensity. Same thing, the gravitational field strength cannot be limited. Like it get weaker as we move away from the charge, electric field get weaker as we move away from the charge, gravitational field get weaker as we move away from the mass. But we cannot say at any point it is zero because of the isolated charge. It will decrease, but it cannot be zero in that case. If there are two different charges or two different masses are there, then some point where the gravitational pull balances, that point the value of the gravity will be zero. But for isolated charge, it will have an infinite range. Both are the types of field, and the force vary inverse. They follow the inverse square law. Like the strength of electric field is inversely proportional to r square, and strength of the gravitational field is also inversely related with r square. How they are different from each other? What are the differences? So how they are different from each other? The gravitational fields are the region in which the mass can experience a force due to its, like the object can experience the force due to its mass. And electric field is a region in which charge experience force due to a charge. Electric field can be attractive, can be repulsive, like charges repel, unlike charges attract. Whereas gravitational field can never be repulsive, it is always attractive. And object can be shielded by electric field but not by gravitational field. Like example, say I have a positive charge here and I have a negative charge. If I introduce another charge here, any charge I introduce, positive or negative, so force which they were experiencing before and force which they are experiencing after, that will be different. Or like example, we have a positive and a negative charge and we introduce another positive charge. So as a result, when we introduce another positive charge, like charges repel each other. So there are regions where the electric field, there are no electric field lines or there is no electric force. So if I place an object here, a charge q here, so this charge q will not move towards right, left, upward or downward because it is being shielded or it is protected by the electric field around it, but it is not experiencing any electric field. So a particle, a charge can be shielded in electric field. Like there will be regions, but not the matter, like the mass cannot be shielded. So gravitational field, there is no shielding. If we have two objects, we introduce another particle, another massive object or another piece of matter, they will all experience the gravitational field. We cannot make the gravitational field zero on this one. So electric field can be attractive, can be repulsive, but gravitational field is always attractive. And we can, in other words, we can say the electric field can cancel or can be reinforced, but the gravitational field always reinforce one another. An object can be shielded by electric field, but object cannot be shielded by gravitational field. And the force between the unit charge at a given separation is much stronger than the force between the unit masses. Like if we have two objects, they have the same mass and charge and they are placed at equal distance from each other. So example, charge Q1 and Q2, example, they have the same mass and same charge. So because of the charge, they will have a electric field. Because of the mass, they will have a gravitational field. So when we compare the force of the gravity or electric field, what we'll find for a same distance, the two charges will have a stronger electric field as compared to gravitational field. So force between the unit charges at a given separation is much stronger as compared to force between the unit masses. Like if we have 1 Coulomb charge and 1 Coulomb charge, they're separated by distance, example 10 meter, and we have 1 kilogram mass and 1 kilogram mass, and they are separated by a distance of 10 meter. So when we compare the strength of the electric field with the strength of gravitational field, so electric field is much stronger as compared to gravitational field. So this was about the comparison between the electric and the gravitational field. So we can also use this gravitational field to find the time period of the satellites, how much time the satellites will take to revolve around the earth, or how much time they will take to complete their one cycle. So we can use this to find the orbital period, how much time the satellites are taking to revolve around the Earth. So example, this is our Earth, and say the satellite is, so first we are finding the time period of oscillation. Uh, so this satellite is revolving around the Earth, and the distance from the center of the Earth to the satellite, that is r. Basically, r is radius of Earth plus the height above the Earth's surface. So re plus h is equals to r. The mass of the Earth is me. The mass of the satellite is m. So according to Newton's law of gravitation, that the force of attraction between them is equals to g, the mass of Earth, mass of the satellite divided by r square, where r is equals to radius of Earth plus height of the satellite above the Earth. And because this satellite is revolving around the Earth, so whenever object move in a circular path, so there is a force which we call centripetal force, and centripetal force is equals to m, the mass of an object, v square, the speed at which the object is moving, squared, divided by r. So when we compare, because the gravitational force is acting toward the center, so force of the gravity, here in this case the force of the gravity which is acting toward the center is actually equal to centripetal force. So gravitational force is equals to centripetal force. So we can compare the two formulas with each other. So we can say the gravitational force is equals to centripetal force. Gravitational force is g, the mass of the Earth, the mass of the satellite divided by r square, which is r is actually the sum of radius of Earth plus height of the satellite above the Earth atmosphere. And the centripetal force is given by mv square over r. So when we simplify this formula, so m will cancel with m, one of the r will cancel with the square, so we are left with g, the mass of the Earth, the radius, over v square. This formula can be used to find the speed of the satellite. That's how, before even we launch the satellite, we can work out what speed we should move the satellite so it maintain a constant orbit. So we'll take a root here. So v is equals to under root g, mass of Earth, over the distance above the Earth atmosphere plus the radius of Earth in a root, will get the speed of the satellite. But how to find the time period, because that's the main part we are doing. So how to get the time period from this same equation, example this equation A. So we have the formula speed is equals to distance over time. As a satellite is revolving around the Earth, so as this satellite is revolving or moving around the Earth, so it's moving in a circular path. In circular path, what is the distance travel? The distance travel is equals to circumference, which is 2 pi r. And the time it will take to complete its one rotation, that is called the time period. So we can say the speed is equals to 2 pi r divided by t. So when we simplify this formula, we have this formula, we are taking g me over r equal v square. So we have the formula g me over r v square, and we work out that v is actually distance over time for a satellite, so it is 2 pi r over t. T is the total time to complete one vibration or rotation, not vibration here, rotation. Vibration is when it just to and fro from its mean position, and rotation is when it returned back to the starting point after completing one cycle. So that is G me over R. If I substitute the value of the V here in this equation, so it will be 2 pi R over T, and then it will be square. So that is G me over R equal to square will be 4 pi square R square over T square. When we simplify, this R is divided, other side will be multiplied, and T square is divided, other side multiplied. So this will be G me T square is equals to 4 pi R cube. Or when we write the last formula to get the time period, so T square is equals to 4 pi radius of earth square, sorry, radius of earth cube divided by G me. So 4 is constant. So this is a formula which we can use to find the time period of a satellite. T square equal 4 pi radius of earth. This is not radius of earth, this is actually radius of earth plus height of the satellite above that atmosphere divided by GME. And we know this all is constant, 4 is constant, pi is constant, G is constant, and M is constant. So all constant are there. So we can say T square is proportional to R cube. So this is known as the Kepler's second law, which shows a relation between the time period and the distance of a satellite from the center. So this is simpler formula which we will use to find the orbital period. So this was about the gravitational field strength, strength of the gravity, and the comparison between the electric and the gravitational field, the formula which we can use to find the mass of the earth, and how to find the orbital period or the time period of the satellite.